An aircraft designed with stealth in mind. An aircraft expected to operate from aircraft carriers far out at sea. And an aircraft that could become one of the most significant additions to China's rapidly modernizing military aviation. This is the story of the J-35. Unlike many famous fighter jets, the J-35 has not built its reputation through decades of operational service or publicly documented combat. Instead, much of the world's attention has focused on its development, engineering, and the role it could play in the future of China's air power. Although many details remain officially undisclosed, the aircraft has become one of the most closely watched military aviation projects in the world. As China continues expanding its naval capabilities and investing in advanced aerospace technology, the J-35 represents more than simply another fighter aircraft. It reflects a broader effort to strengthen carrier-based aviation, improve long-range operational flexibility, and develop modern combat systems that can operate in increasingly complex environments. But what exactly is the J-35? Why was it developed? What technologies make it different from previous Chinese fighter aircraft? And perhaps most importantly, what do we actually know based on publicly available information, and what remains uncertain? Throughout this documentary, we'll focus on verified information wherever possible and clearly distinguish confirmed facts from informed analysis. That approach helps build a more accurate understanding of an aircraft that continues to attract global attention. To understand the importance of the J-35, we first need to look at how modern air combat has changed over the last several decades. During much of the Cold War, military aircraft were often judged by a handful of performance figures. Maximum speed, climb rate, turning ability, and altitude were considered the defining characteristics of an advanced fighter. Engineers competed to build aircraft that could fly faster, climb higher, and outperform opponents in close-range maneuvering. Today, the priorities have evolved. Modern air combat places far greater emphasis on information. Detecting an opponent before being detected can provide a decisive advantage. Instead of relying solely on speed or agility, today's most advanced aircraft are designed to combine low observability, powerful sensors, secure communications, and sophisticated onboard computing into a single integrated system. This is where the concept of a fifth-generation fighter becomes important. Although different countries may define the term slightly differently, fifth-generation fighters generally combine several key characteristics. These include reduced radar visibility, advanced sensor integration, high levels of situational awareness, secure data sharing, and the ability to perform multiple mission types within a single platform. Reducing radar visibility, often referred to as stealth, is one of the most widely recognized features of these aircraft. However, stealth does not make an aircraft invisible. Instead, engineers attempt to reduce the distance at which radar systems can reliably detect and track the aircraft under certain conditions. Achieving this requires careful shaping of the airframe, specialized materials, and thoughtful integration of external components. The United States introduced operational fifth-generation fighters with the F-22 Raptor, followed later by the F-35 Lightning II. Russia developed the Su-57, while China introduced the J-20 as its first operational fifth-generation fighter. The J-35 is widely understood to represent another step in China's fifth-generation aviation program, with particular attention given to carrier operations and naval aviation. This naturally raises an important question. If China already operates the larger J-20, why invest in developing another stealth fighter? The answer appears to lie in operational requirements. Although both aircraft are considered fifth-generation designs, publicly available information suggests they were developed with different missions in mind. The J-20 is generally regarded as a larger aircraft designed for long-range operations, carrying significant fuel and advanced sensors. Its size allows it to support missions requiring extended range and endurance. The J-35, on the other hand, appears to place greater emphasis on flexibility and compatibility with aircraft carriers. Operating from an aircraft carrier introduces engineering challenges that do not exist for aircraft based on conventional runways. A carrier's flight deck is only a fraction of the length of a typical runway. Aircraft must launch using specialized systems and recover by landing on a moving ship. while engaging arresting cables within a very limited distance. These demanding conditions place tremendous stress on landing gear, airframe structures, and flight control systems. Engineers must strengthen critical components without adding excessive weight. They must also consider maintenance, storage space, corrosion resistance, and the practical realities of operating in a harsh maritime environment. Because of these unique demands, many countries design dedicated naval aircraft instead of simply adapting existing land-based fighters. Publicly available evidence suggests that the J-35 has been developed with these naval requirements in mind. To understand how the aircraft reached its current stage, we need to look back at its origins. The story begins not with the name J-35, but with another designation that attracted considerable international attention more than a decade ago. During the early 2010s, China's Shenyang Aircraft Corporation introduced an experimental aircraft commonly known as the FC-31. At the time, many observers believed it was intended primarily as an export product for international customers rather than for domestic military service. The aircraft demonstrated several design features associated with modern stealth fighters, including internal weapon bays, angled tail surfaces, and a streamlined fuselage. Although information remained limited, the FC-31 showed that Chinese aerospace engineers were actively exploring multiple approaches to fifth-generation aircraft design. Over the following years, the program continued to evolve. New prototype aircraft appeared with noticeable structural changes. Observers identified redesigned landing gear, modifications to the airframe, and other features that appeared more consistent with carrier operations. These developments led many defense analysts to conclude that the program had shifted toward supporting the People's Liberation Army Navy rather than focusing solely on export opportunities. However, one important point should always be remembered. Official information regarding the program remains relatively limited. Much of what is discussed publicly comes from photographs, satellite imagery, patent filings, airshow appearances, and technical assessments produced by defense specialists. While these sources can provide valuable insight, they should not be confused with official confirmation. Responsible analysis requires acknowledging where certainty ends and informed assessment begins. This distinction is especially important when discussing military technology, where complete technical specifications are rarely released publicly. The growing attention surrounding the J-35 also reflects broader developments taking place within China's Navy. Over the past 2 decades, China has significantly expanded its investment in aircraft carriers and supporting naval infrastructure. Aircraft carriers extend a nation's air power far beyond its coastline. Instead of relying exclusively on land-based airfields, they allow combat aircraft to operate alongside naval task groups across vast maritime regions. Operating aircraft from a carrier increases operational flexibility, but also requires extensive training, specialized maintenance, and highly coordinated flight operations. Developing a capable carrier air wing is therefore much more than building a new aircraft. It involves pilot training, deck operations, logistics, maintenance systems, and the integration of aircraft with ships, command networks, and supporting assets. As China's carrier fleet has matured, the demand for modern carrier-based aircraft has naturally increased. This broader context helps explain why the J-35 has attracted so much international interest. It is not simply another fighter entering development. It represents part of a wider effort to expand carrier aviation and develop the technologies required to support future naval operations. The aircraft's final capabilities, production numbers, and operational history remain subjects that will become clearer over time as more official information becomes available. For now, the J-35 stands as an example of how modern aerospace engineering combines aerodynamics, materials science, propulsion electronics, and software into a single highly integrated platform. In the next part of this documentary, we'll examine the aircraft itself in greater detail, exploring its design philosophy, stealth features, structural engineering, and the technologies that shape its performance while separating confirmed facts from informed analysis.